Welcome everybody to the OxTS webinar on RT range software. This is done by my colleague Kit Behard. This webinar will be recorded and will last around 30 minutes, and then there'll be time at the end for questions. And you can submit your questions throughout the webinar using the question box on the webinar software.
Thank you, Lily. Yes, we'll begin the webinar now. As my colleague said, this will be an introduction to the RT range software, but before we go into the software, I just want to give an overview of the hardware that this software is designed for. So the RT range products that we offer, there are a couple of generations. The latest generation, the V3, the range functionality is contained in the RT3000 V3, which is a combination of RT and range functionality, whereas the previous generation, version 2, there were two separate bits of hardware. The RT3000, which contains the inertial sensors and the GNSS receivers, which would measure the position and dynamics of the vehicle. And then a separate RT range hunter box and target boxes for the target vehicles, which took the navigational messages from the RT and the hunter and target vehicles and processed them, the measurements from them to output range measurements. So just to have a look at the RT range suite. The software contains 6 different applications. Configure RT range, which is used for setting up the RT range. Then we've got feature point survey, lane survey, and map creation, which are all tools for surveying your test area. Real-time display, which is used for looking at the measurements in real time. And then post-processing, which we won't go over at all today because it is there is a separate webinar solely based on how to post-process RT range data. So let's begin. Before you can start your test, you may need to survey your area for things like lane markings or points of interest like traffic cones or traffic lights, road signs, anything that the sensors on your vehicle might be trying to pick up that you want to validate that they are picking up at the relevant times. And for doing these kind of surveys, we use a survey trolley and then specific software. So the first, this is a photo of my colleague using the survey trolley to survey some lane lines. And the first software I'm going to look at is the lane survey wizard, which my colleague would have been using then whilst pushing the survey trolley. So this wizard is a very simple tool. You only need an RT unit for this. You don't need to have the range system set up yet. So this software simply takes the position and heading of the RT, and you sort of push the survey trolley to the start of the line, and then you can monitor the RT's position and heading, but also its accuracy in some measurements in the top right-hand corner, which are labeled here. So you can see you've got the number of satellites, position mode, its speed, and then this cursor in the middle is showing you your heading and current position. So once you've lined that up into the start of a line, you can use this add point here button, and that simply saves your position as a point. You can see the lat long positions here. There's also altitude. And then you have a couple of options. You can either use this add point here button to manually add points as you push the trolley along the line, or you can use this auto add feature, which will add a point every 10 meters, or the distance is configurable, so however many meters you like, or you can configure it to add a point for a certain duration, or you can add a point using the trigger switch, which comes with the survey trolley. So the important thing to note here is if you had a few lanes that you wanted to survey, you have to survey each line individually in the software. So you would open the software, survey the first line, and then once you'd reached the end of the first line, you would use the finish options, save and start new line. This would sort of give you a fresh canvas, and then you would start to survey the second line of your test area, save and start new line again, and then you would survey the final line. Or you can survey up to 8 lines. This is just to prevent the software from joining up the lines if you when you're creating the map. So by having 3 separate lines, you're having 3 distinct lines in the map rather than connecting them all into one single line. So it would be like an S shape if you didn't survey the lines individually. So at the end of this survey, you would have 3 line files for this double lane road here. You would then need to combine these line files into a map file, and we have a tool for that called map creation. And I'm just going to go through, I'm going to open up the map creation tool now and give you an example of how to create a map. So when you open the map tool, it will be completely blank. And then you have a couple of options here on the side. The option that you'll need most is the add new line option. So this is where you need to locate your line files. I've made a couple of examples for us to use. And then once you've selected all the files you want to load into your map, you are given an option to either use the forward direction or to reverse the direction of your map file. The reason you're given this option is because the quickest way to survey multiple lines is to push the trolley in one direction up the first line and then in the reverse direction in the second line, and sort of alternating forwards and backwards. But when you're adding the points, you're actually saving the heading of the trolley as well. So it will, the lines will actually know which direction you've pushed the trolley in. And so to ensure that the points are all facing the same direction, you'll need to reverse the alternating, so reverse the direction of the lines you've pushed the trolley in the reverse direction. So by reversing the second line, you can see here, if I zoom in a bit, you can see that the heading on all of these points is pointing the same direction. So once you've added all your lines in, the only other thing you need to do is to define the start line for your map. So to define the start line, you just need to double click on a point that you would, the point that represents the start of the map for you. This will highlight the point in the measurements table on the right hand side. You just need to right click, set start line from this point, and you'll see a line is generated in the software. So the line is generated perpendicular to the heading of the point. And the significance of the start line is that once you have loaded this into your RT range device and you've set your vehicle up, the vehicle only starts to output lane measurements once you've crossed the start line. And the direction at which you cross the start line matters as well. So it only starts outputting lane measurements if you cross the start line driving in the direction of the heading of the point that you've used to define the start line. So for this example, the heading of this point is facing to the top left corner. So when you drive in this direction here, you'll cross the start line and start to output lane measurements. But if you're driving this direction, the lane measurements won't start. So once you've finished that, you can simply save and quit. And that is the map creation tool. The other software we provide for doing a survey is the feature point survey tool. This software is almost identical to the lane survey tool, but it has a different application in mind. So where the lane survey tool is for surveying lanes, the feature point survey is for surveying the position of important features in your map. And so because these features can differ and you want your RT range to know or to be able to distinguish them, the software allows you to add a description. So in the measurements column here, you can see each feature point which is added has a description. And to edit the description of the feature point, you need to just double click it and it will bring up the feature point editor and allow you to input a description here. So your description would be like traffic sign or a description of whatever the feature point would be. It also gives you an option to offset the position. So if you've set up the survey trolley and you've pushed it as close as you can to the point which you want to survey, but there's some sort of barrier that's preventing you from getting any closer, you can just measure from the RT to the feature point and then introduce an offset this way, so that the position of that feature point is accurate. So that's all of the surveying tools. Once you have surveyed your test area and you're ready for your test to begin, you will just need to configure the RT range hunter for the test. So I'm just going to open up the configure RT range application now, and I'll just take you through an example configuration. This is the configuration wizard. You can see there are 3 options here at the top. If you haven't configured your device before, I recommend using the default settings. The other options you have are to read from a file. So if you had previously configured a RT range system and saved it locally onto your computer, you can read back from that file. Or the other option is if you have a unit that you're connected to, it will probably have a configuration file already on the unit. So you can read the settings from that file as well. But for this example, I'm just going to go through using default settings. Once you have made this decision, you just need to choose which product you're configuring as well. So as I mentioned before, there are sort of 2 generations, the RT Range S Hunter, but also the RT 3000 V3. And it gives you an image of the product so that you can sort of visually confirm which one you have as well, if you're unsure. Currently on the bench, I have a RT Range S Hunter, so I'm going to configure this. And then the first option is if for a RT range S hunter, you need to associate an RT to that hunter as well, because the range system for the V2s doesn't have any inertial sensors in it. It needs an RT, like an RT3000, to provide the navigation information of the hunter vehicle. So you need to select the IP address of the RT that you have in the vehicle with that RT range hunter. The RT range systems can accommodate up to 4 targets, and these targets can be any combination of mobile targets, so that's another vehicle with an RT inside that you have a connection to via some sort of wireless antenna. We provide RTX LANs, which are Wi-Fi antennas for the purpose of connecting hunter to target vehicles. And then you just need to choose the IP address of the RT in the hunter vehicle here as well. The other form of target is a fixed point. So this is a stationary saved location which the RT will output its distance and range to. You can define this location by either like inputting the position if you have a pre-surveyed point which you wish to use, or you can use the current position of an RT on the network. So for this example, I'll just create a fixed point using the current position of the RT I have on the work surface, and I'll just offset it 10 meters forward and 10 meters right. And then the final target you could configure is a feature point target. So this is for the occasion where you've done a survey of the features in your test ground. You've created a file which contains a list of all of these feature points, and you just choose the target as a feature point, and then you can upload the file if you have one saved. And the number of feature points you can pick up at any one time is determined by how many of your targets are set to be feature points. So in this example here, I'll always be tracking one mobile target, one feature point, one fixed point target, and then the last 2 targets will be feature points, which will change as I drive around, and I'll explain that a bit more later. And for now, I'm just going to use the same RT as my hunter and target, so they will appear on top of each other, but this is just because I only have one RT at the moment. So the next step for configuration is to measure where your RT is in the vehicle and choose a point on that vehicle that you wish to output measurements from. So typically, RTs are installed in the center of the vehicle. We provide a mounting system called an RT strut, which you just insert like in front of the passenger seat, and it just keeps the RT rigid in the center of the vehicle. But you might, if you're doing like an A/B test, for example, you might not really care about the center of the car. You might only care about the front bumper and how close that front bumper is to your target vehicle. So in that scenario, what you need to do is, so this is the point where you want your output to be from. So you'd move this to the front bumper, and then you would measure from the front bumper to your RT and insert those measurements as a lever arm. So if the RT was, if the front bumper was 2 meters forward of the RT and half a meter right, you would enter those measurements and then the RT would automatically be put in the correct position. You're given the same options for any mobile targets you've set up, so targets with an RT in, also any fixed point targets, but you don't get this option for feature point targets. Feature point targets are always just one-dimensional points with a description, but that's all the functionality that they get. So the next thing you can do is if your test is a bit more complicated and you care about more than just the front bumper, you also care about so if you're doing like an overtake maneuver, for example, you might always want to know which 2 points of the vehicle are closest together. For these kind of scenarios, you can use polygons. So polygons are sort of 2D profiles of the vehicle. In this example, I'll just add 4 polygon points to define my polygon. And I'll just create a rectangle. You can drag and drop the points where you like. It's a very quick option if you just want a quick test. But if you are looking for accuracy, the best thing to do is to measure from the sensor point location. So not where the RT is. So you first choose, like before, you would choose the front bumper as a special location. And then you would measure from that special location to various points on the outside of your vehicle, and you can input those measurements here to make it extra accurate, rather than dragging and dropping the points in the software. So the polygon just allows you to create the shape of your vehicle and output measurements always from the outside of your vehicle, rather than just from one point, like rather than just outputting from the RT or the front bumper. If your cars were sort of parallel to each other, then their closest points might be the wing mirrors, and by setting up a polygon like this, you'll output from the nearest point. You can have up to 24 points on your polygon. And this allows you to really add some detail to the shape of the vehicle, so really defining the outline of the wing mirrors and stuff like that. And once you've put a lot of time into creating a polygon, you can save it. And then use it again for anytime you've anytime you use that vehicle again in the future, you can load up that polygon again. Just clicking the load button here. If you have, so here there are some other saved files. Just give you an example of a polygon someone's put a bit more time into to really get the shape of the car. So another function that was released December 2018. So if you have quite recent firmware, you'll have this option to enable multi-sensor points. These are extra points on the vehicle where you would wish to output measurements from. So for example, if your car had lots of sensors which you wish to validate at the same in one test run, you could set up a multi-sensor point on each of the sensors. And the multi-sensor point gives you extra output, so it gives you the range to a target from that sensor point. It also gives you the visibility of the target in that sensor point's field of view. So you can see here, you can define a field of view with a half angle and a minimum and maximum range, and also like an offset. So currently one has the field of view facing out front of the vehicle. If I set 2 to be facing left, that would be an angle of 270 degrees. 3 is going to be facing out the back, so 180 degree angle. And then 4 will be facing out right. And I'll show you how this appears in the software as well. I'll just increase their max range a bit. And you can give these sensor points names as well. So if you have one which is a camera and one which is a LiDAR, you can label them here as well. And then the last thing to go over here is the feature point field of view. So I said before that if you had previously surveyed some feature points in your test area, you can define a field of view so that only feature points within the field of view appear as targets. That's because you can have, so that the limit for the number of points you can add to a feature point file is 65,000. But you won't want to know your range to all of these points at one time, and it would overload the processor. So the functionality works that you choose a field of view, and then only the closest feature points in that field of view will appear and output data. And then you only get the sort of data to the relevant feature point at any one time in the test. And here is the option for setting that field of view here. So now we move on to the lane measurements. So if you have pre-surveyed a lane, your lane measurements will be from 3 points, A, B, and C. And these 3 points are supposed to represent the center of the vehicle, the far left and far right point. So points B and C are supposed to be the points in the vehicle which would cross the lane first. And then point A is supposed to be used to define which lane you're in at any one time. And you can see here that the measurements for point A, B, and C are relative to the sensor point you set up in the Hunter section. So currently the reference point has been moved to the front bumper. So you can see point A, which is currently 0, 0, 0, is also on the front bumper. And then B and C are 1 meter left or right of that point. But you can measure from the sensor points to, if you know exactly where you want your lane measurements to be output from, you can then enter those measurements here. Finally, there are some options. So you can set up CAN output. Lots of measurements. You can get measurements from the Hunter RTs and all of the target RTs, as well as all the range measurements from target 1, target 2, and target 3, target 4, and all your lane measurements as well. So lots of options for CAN. There's a warning message here for the local coordinates, and that's just because we've set up polygons which are 2-dimensional. So they require a 2-dimensional coordinate system to be plotted correctly. So you need to set up local coordinates the easiest way to set up local coordinates is to use nav display. So this is nav display. This is a real-time tool which is included in the nav suite software, and it's used for monitoring the status of an RT. So currently this is the RT I have on the bench, and if you go into utilities, quick config, you can choose the encom stream of the Hunter RT, go to local coordinates, and you can just use your current position of the RT to set your local coordinate origin. So if I set origin now and close and exit this, then I should be able to copy that here. So now I've set it up in the RT quickly in nav display, and I've just copied those coordinates into the range. So now I'm just going to commit that and finish. So that's configure RT range. There's a lot of options to configure in there. Sorry, I spent a while going through them all. So next we're going to move on to real-time display. I do have some screenshots, but because I have a unit running on the bench, I'm just going to load that up. So you'll be given two windows will pop up when you load this up. Nav Connect just shows you which units you have on the bench or you're connected to, which are outputting streams. So here I have one RCOM stream from the Hunter and one stream from the RT. And if I use, so bird's eye, so this is the real-time display window, and you can see here there are a list of measurements. You can configure what measurements are contained in this list using the configure display, or you can use one of our pre-made templates as well. And then bird's eye view is a better view for sort of seeing what's going on in the test. Gives you like a top-down view of where your Hunter and targets are. So this is the origin view. So you'll only be able to see this view if you have set up local coordinates. As you can see, it's in the XY plane. And this is the view you will use to see what polygons you have set up. And you can also see the field of views of your multi-sensor points that you've set up. And you can enable or disable the field of views of the multi-sensor points if you find that distracting. And then to see the measurements of each multi-sensor point, you just go to the target that you're interested in. So maybe target 2, and then go to the multi-sensor point target, and you can see here that target 2 is being picked up in sensor 4, which you can see is this one here. It's 2 meters away from the multi-sensor point. 89% of the target is visible, and it's occupying about 40% of that sensor point's field of view. And we're running low on time, but I'll just quickly show you the start logging utility as well. So all of our units output data in real time, and you can log this data just by opening the data logging stream module and selecting the streams which you wish to log. Choose the file that you want, the working directory and file name. So if I just do test and then start logging, just instantly starts capturing all of those streams and saving them to file. And that's a quick overview. We've run over 5 minutes, so I'll stop there and we can start going through any questions that you might have.
Okay, thank you for that.
So,
we have had some questions in. If people do have any other questions, they can just ask them now and we'll go through them. Okay, so the first question, should the polygon origin be the RT range device or the RT3000 device?
Okay, yeah, so the polygon origin, I'll just open up the software now. So I'm just going to read back that configuration I loaded up. I'll do it on a target without any. Okay, so you can see here there are two points apart from the polygon points. You have the INS position and the reference point of the polygon, which is also the polygon origin. The polygon origin isn't your RT or your RT range. It is a point which you choose on your vehicle that you are going to make your measurements from. So you're going to pick a point on your vehicle, you're going to drag the polygon origin to that point on the vehicle, and then from then on, all measurements are going to be made relative to that point. So you can see here, these measurements are the forward and right measurements of each polygon point. If I move this RT around, you can see that those measurements aren't changing. Whereas if I move this reference point, all of the measurements change, and that's because all of the measurements are relative to that point. So you want to pick a point on your vehicle which is easy to measure from. This is why we've introduced this feature, is because it's very difficult to measure from the center of your vehicle to 24 points on the outside of the vehicle. Whereas if you pick a point on the outside of the vehicle already, so if you choose a point, doesn't have to be the front bumper, I've just chosen that as an example. But if you have chosen the front bumper, it's a lot easier to measure from the front bumper to other points on the outside of the vehicle than it is from where the RT or the RT range device might be.
Okay, thank you for that, Kate. So the next question, what is the purpose of making map creation? Is it used for autonomous driving?
So there's a limitation to the maps that can be created in the software, and that limitation is the number of lines you can use. So you can only use a maximum of 8 individual lines. This makes the map creation tool lend itself more to ADAS testing. So tests like LKA or LDW, where you have just a few lanes and you want to know whether your vehicle is departing the lane, rather than very complicated maps. So for example, in autonomous testing, you might have a test area with lots of junctions, roundabouts, because you're testing how the autonomous car will be coping with urban environments. These maps, I think, will be too complicated to create with just 8 lines. And I haven't seen any maps which are sort of these kind of mini cities. All the maps I've seen created are sort of a number of lanes for like an ADAS scenario.
Thank you, Kit. Is there a way in which you can have a moving polygon with an input of some kind, e.g. for a truck, so as it changes, like relative to the wheels, the wagon kind of thing?
Okay. So for a truck, if you have you've got the sort of two sections, you've got the cab and the trailer, to have polygons set up which move separately, so one which moves as the trailer moves and one which moves as the cab moves, you will need an RT in the cab and an RT in the trailer, because you'll need something like an extra device to measure when that trailer is moving. So you won't be able to do that just with a single device, because they're moving independently of each other, or like there will be times when they move independently. You will need an extra device to measure the movement of each compartment separately. And then you'll have to set up the cab as a target one, so as like a mobile target, and create a polygon around that.
Thank you, Kit. Another question on polygons here. What is the use of polygon points, and is it optional or mandatory to use?
It's very much optional to use. So if I show you the real-time display again. It seems to have, I have a poor setup here. So I think one of the RT units might have gone a bit haywire. Yeah, so basically, if you've got a simple test scenario where you are maybe driving in an A/B scenario in a straight line, you know that the closest points between your hunter and target are always going to be the same 2 points on the car. So in that scenario, you're always looking at the distance from the front bumper of the hunter to the rear bumper of the target. In that scenario, it makes more sense to not use polygons, but to only use a scenario like this. So just have one sensor point that you care about. However, there are some more complicated scenarios where the two closest points on the vehicles, your hunter to target, might change throughout the test. And in those scenarios, this configuration would be not suited, because so at the start of the test, you might have the two closest points of the hunter and target to be the front bumper and the rear bumper of the hunter and target respectively. But if your hunter overtook your target, then your two closest points would be the rear bumper of the hunter and the front bumper of the target. But if you hadn't configured polygons, you would still be outputting the range from the front bumper of the hunter to the rear bumper of the target. So it would seem like the two vehicles were much further away than they would be in real life. So by introducing polygons, you're allowing the RT range to know where the two closest points are on the vehicles, regardless of their orientation with each other.
Okay, thank you for that, Kit. Do we have any more questions from anyone? We are now at the end of the webinar, and that is all the questions we've had in so far. We are running this webinar again next week. If you do want to see it again, or you can ask further questions to OxTS support@oxts.com. If you just email us, we can answer questions there as well. Okay, thank you for coming, everyone.
Cool. Thanks for listening.